हे गाइस व्हाट्स अप। तो कैसे हैं आप सब लोग। मेरा नाम है सुधांशु और आप देखने आ चुके हैं आपका अपना चैनल फिजिक्स नदी। तो बच्चों, लास्ट वीक कुछ क्लासेस के अंदर हमने गॉस थ्योरम के बारे में बात की थी और हमने गॉस थ्योरम की कुछ एप्लीकेशंस के बारे में बात की थी। तो आज की क्लास के अंदर भी हम गॉस थ्योरम की एक नई एप्लीकेशन के बारे में बात करेंगे, दैट इज इलेक्ट्रिक फील्ड ड्यू टू अ पेयर ऑफ शीट। देखिए, इससे लास्ट क्लास के अंदर हमने क्या बात की थी। हमने बोला था कि दिस इज अ शीट, ओके, एंड ये शीट जो है ये पॉजिटिवली चार्ज है और नेगेटिवली चार्ज है, व्हाटएवर, और इसके एक स्पेसिफिक डिस्टेंस पे हमने इलेक्ट्रिक फील्ड को निकालने की जो है हमने बात की थी, ओके। और उसका जो रिजल्ट आया था, दैट रिजल्ट इज नथिंग बट द इलेक्ट्रिक फील्ड कैन बी इक्वल टू सिग्मा अपॉन 2 एप्सिलॉन नॉट, लाइक दिस, अगर आपको याद हो तो। ठीक है, लास्ट क्लास के अंदर हमने इस रिजल्ट की बात की थी। नाउ वी आर सेइंग दैट कि लेट्स सपोज two sheets are there, okay. This is the first sheet and this is the another sheet. So we are keeping these two sheets like this, okay, and we are trying to find an electric field at different points. See, if this is the two sheets, okay, this is the pair of sheets, so clearly you can see there are three possible regions here. Yes or no? See, one region is here, that means you can say the outside left, okay. One region is here, that is outside right, and one region is in between the sheets, okay. So we have to find the electric field at all three regions which I have marked here. The one region is outside left, outside right, and inside, and here also outside left, outside right or inside, okay. Now आप बोलोगे कि सर दो डायग्राम्स क्यों बनाए हुए। देखिए गाइस, अगर दो शीट्स ऐसे रखी हुई है तो ये दोनों शीट हो सकता है कि ये पॉजिटिवली चार्ज हो, ये भी पॉजिटिवली चार्ज हो, ओके, या ये नेगेटिवली चार्ज हो, ये नेगेटिवली चार्ज हो। मींस कि टू शीट्स कैन बी चार्ज्ड लाइकली, सेम चार्ज से चार्ज हो सकता है, लाइक दिस। सी, दिस इज पॉजिटिवली चार्ज, दिस इज पॉजिटिवली चार्ज, ओके, एंड in second condition they can be differently charged. Yes or no? See, like this, one sheet can be positively charged and another sheet can be negatively charged, okay. So both conditions can be, जो दोनों कंडीशन है दोनों में से कुछ भी हो सकती है। तो सबसे फर्स्ट हम सबसे पहले बात करेंगे जब दो शीट्स कैसी हैं, जब दो शीट्स लाइकली चार्ज है, okay, likely charge, okay. So first of all we will talk about electric field in this particular region, okay. So if I am going to tell you the see, if we are going to calculate the electric field at outside left, okay, so see what happened. देखिए, इस पर्टिकुलर शीट के ऊपर जो है वो पॉजिटिवली चार्ज है, तो इसकी जो इलेक्ट्रिक फील्ड की डायरेक्शन है वो भी कैसी होगी, लाइक दिस। This is electric field. Let's suppose this electric field as a E1, okay. So what is the formula for electric field? That is nothing but the sigma upon 2 epsilon naught. Yes or no? Okay. And see here I have mentioned the charge density for this plate is sigma 1. So this can be written as sigma 1. Yes or no? And एक और चीज आपको यहाँ पे कंसीडर करनी है कि whatever electric field which is going to the left, whatever electric field which is going towards the left, we have to mark a negative sign for that electric field. Okay? Okay. So this is the first electric field at outside right due to this sheet. And देखिए, इस शीट की वजह से भी इलेक्ट्रिक फील्ड होगा और इसकी डायरेक्शन कैसे होगी, सेम डायरेक्शन लाइक दिस। इट विल आल्सो एक्ट इन दिस पर्टिकुलर फैशन, ओके। सो वी विल कंसीडर दिस इलेक्ट्रिक फील्ड एज E2, ओके, एंड व्हाट इज द फॉर्मूला, दैट इज सिग्मा अपॉन 2 epsilon naught, okay. And what is the surface charge density for this sheet, that is lambda, sorry, sigma 2, so it will become sigma 2, and this electric field is also acting towards left, so we will place here a negative sign, isn't it? Okay. Now we will see at inside, okay. First calculate the electric field for outside left, okay. So we will calculate here electric field outside left, okay. So if you will tell electric field at outside left, what will happen? See, these two electric fields are just acting towards left, so we have to add these two, okay. So if you are going to add this E1 and this E2, what you will find that minus 1 upon 2 epsilon naught will become common, and sigma 1 plus sigma 2 will become like this. Okay, if you are going to add this one, this thing will come. Okay. Now we just make a special case here. What is the special case here? See, मैंने यहाँ पे बोला है कि चार्ज डेंसिटी फॉर दिस शीट इज लैम्डा 1 एंड फॉर दिस शीट इट इज लैम्डा 2, बट नाउ आई एम टेकिंग कंसिडरेशन हियर दैट द चार्ज डेंसिटी लैम्डा 1 कैन बी इक्वल टू लैम्डा 2 एंड बोथ कैन बी इक्वल टू लैम्डा। दैट मीन्स कि अब मैंने क्या कर दिया, अब मैंने मान लिया कि हमारी जितनी भी चार्ज डेंसिटी है फॉर दिस शीट एंड फॉर दिस शीट, द चार्ज डेंसिटी फॉर दीज टू शीट्स आर इक्वल। तो अगर ये चार्ज डेंसिटी इक्वल होगी तो क्या होगा, सी फॉर दिस पर्टिकुलर रिलेशन वी विल राइट दैट E is equal to, that is minus 1 upon 2 epsilon naught, and sigma plus sigma it will become 2 sigma like this, and 2 and 2 will get cancelled, and what is the final formula, that is minus sigma upon epsilon naught. Yes or no? This will become minus sigma upon epsilon. So this is for the electric field outside left with different distribution or with a same distribution. Okay. Now we will talk about the inside. See guys, here if I am talking about the inside, the direction of electric field is like this for this particular region. This can be called as E1, and E1 is nothing but this sigma upon 2 epsilon naught. See here, but direction is towards right, so positive sign will be there. Okay. See, for this particular outside right, it will become like this. This is the direction of electric field. You can say this is E2, and this can be equal to sigma 1, and this will become sigma 2 upon 2 epsilon naught. Okay. The direction here is towards left, so we will fix a minus here. तो अब यहां पे हम कैलकुलेट करते हैं इलेक्ट्रिक फील्ड इनसाइड. ओके. If we calculate electric field inside, what will happen? See here, the one electric field is going towards right, and one electric field is going towards left. So we have to add these two. Okay. So if we are going to add this one, how we will get? We will get a 1 upon 2 epsilon naught, and here it will become a lambda 1 minus sigma 1 minus sigma 2. Okay. So see now again here, if I'm going to consider that both charge densities are same, then what will become? This E will become that 1 upon 2 epsilon naught, and sigma 1 minus sigma 2 both are equal, that will become 0, and this entire thing will become 0. So here the electric field inside these two plates is 0. Okay. Like this. Okay. Now we will move to the third condition, see, which is outside right. If I'm going to calculate electric field here, due to this sheet lambda 1, the electric field will be act like this, and this E1 can be called as sigma 1 upon 2 epsilon naught. Isn't it? Okay. Now we have to calculate the electric field due to this particular sheet. So this can be called as electric field 2. So this can be written as a sigma 2 upon 2 epsilon naught, because we both are acting towards right, so the positive sign will be there. Okay. So now we will calculate electric field that is outside right. Okay. Electric field outside right. So if you are going to add these two, it will become the 1 upon 2 pi epsilon naught will become will take common 1 upon 2 pi epsilon naught, and here it will become lambda 1 plus lambda 2. Okay. Now if the charge densities are again same, then this equation will become electric field is equal to 1 upon 2 epsilon naught, and this sigma plus sigma will become 2 sigma like this. 2 sigma and 2 will get cancelled. It will become sigma upon epsilon naught. Okay. So these are the three different conditions. देखिए बच्चों यहाँ पे 3 रिजल्ट आए हैं इस तरफ 3. That means there is total 6 result is there when the sheets are likely charged. जब ये दोनों के ऊपर सेम चार्ज है, तो ये आपकी 3 कंडीशंस है जहां पे चार्ज डेंसिटी क्या है, डिफरेंट है. यहाँ पे जो डेंसिटीज हैं, जहां पे जो चार्ज डेंसिटी है वो क्या है, डिफरेंट है. ओके. लाइक द चार्ज डेंसिटी ऑफ वन शीट इज सिग्मा 1, अनदर के लिए सिग्मा 2. ओके. बट यहाँ पे अगर चार्ज डेंसिटी अगर सेम है तो क्या होगा, यहाँ पे इलेक्ट्रिक फील्ड कुछ इस तरीके से. Okay. Now we will move to our next part in which charges are the sheets are differently charged. Okay. So if sheets are differently charged, so first of all we will take condition for the outside left. Okay. See, in this region, electric field due to this positive charge is like this. Okay. So this can be called as E1. Okay. This can be called as E1. Or E1 can be written as what? That is sigma 1 upon 2 epsilon naught with minus sign because it is coming towards left. Okay. And for this particular reason, what is the direction for this particular sheet? This is negative. You know the electric field for negative will go like this. Yes or no? So what is the E2 here? That E2 is nothing but the sigma 2 upon 2 epsilon naught, which is acting towards right. So it will become positive. Yes or no? So it will become a positive. So now we have to calculate here that electric field due to outside left. Okay. So electric field due to outside left means we have to add these two. Okay, we have to add these two. So if you are going to add these two, you will become that 2 epsilon naught will become a common, and here it will become that sigma 1 minus sigma 2. This is for the when charge densities are different. Okay, one is the charge density of one sheet is sigma 1 and charge density for another sheet is sigma 2. Again we have to place a same condition here also. That is sigma 1 is equal to sigma 2 is equal to sigma. That means the charge density of charges, the sheets are equal. So if you are going to rewrite this equation for the similar charge density, that sigma 1 minus sigma 2 both are equal, this will become 0 and this entire electric field will become 0 here. Isn't it? Okay. Now we will move to the second point, that is inside. अब देखिए बच्चों यहाँ पे inside के लिए क्या होगा? Electric field due to this is like this. Okay. So this E1 can be called as sigma 1 upon 2 epsilon naught, but with positive sign because it is going towards right. Okay. And for this outside right, आपको पता है electric field की direction इस negative sheet के लिए इस तरीके से होगी. So this can be written as E2. And E2 can be written as sigma 2 upon 2 epsilon naught like this. Yes or no? Okay. So these both are acting towards right. Okay. Now we will calculate here that electric field where inside. Okay. So if we talk electric field inside, see we have to add these two. So again you will see that 1 upon 2 epsilon naught will get common, and here we can write sigma 1 plus sigma 2. Isn't it? Here it will become sigma 1 plus sigma. Here we can write sigma 1 plus sigma 2. Okay. Now if I am saying that the charge densities are same, अगर charge density same है तो electric field क्या होगा? See here, this will become sigma plus sigma will become 2 sigma. So it will become 2 sigma upon 2 epsilon naught, and 2 will get cancelled here. So it will become E is equal to sigma upon epsilon naught. It will become sigma upon epsilon naught. Okay. Now we'll move to the third condition for this particular region. See, for this particular region, due to this sheet, electric field direction is something like this. We can say E1, and this E1 can be written as sigma 1 upon 2 epsilon naught. Okay, okay. For this particular region, this electric field will act like this towards the negative charge. So this E2 can be written as sigma 2 upon 2 epsilon naught, but the direction here is minus. Yes or no? So if we will calculate here that electric field which is outside right, electric field outside right. So here also we have to add these two. So clearly you can see the 1 upon 2 epsilon naught will get common, and here it will become lambda sigma 1 minus sigma 2. So this is the condition for outside right. Okay. अगेन अगर मैं बात करूं कि जहां पे चार्ज डेंसिटी सेम है, अगर चार्ज डेंसिटी सेम है तो E will become C here, that is 1/2 pi epsilon, that sigma 1 minus sigma 2 both are equal, so that it will become 0 and 0, that everything will become 0 here. Okay, so देखिए बच्चों यहाँ पे टोटल आपके पास 12 कंडीशंस है. कौन सी? This is for the where the density is different and where the density is same, and here also for the different density, okay, and here for the same density. So here totally we have 12 results, 3 for the different density, 3 for the same density, again 3 for the different density, and again 3 for the same density. ओके, तो देखिए बच्चों यहाँ पे जो चीज समझने वाली है वो क्या है कि अगर मैं आपसे सिंगल शीट की बात करता हूँ, लेट्स सपोज दिस इज द सिंगल शीट. ओके, सो इन दिस पर्टिकुलर शीट दिस साइड इज चार्ज्ड. Okay, let's suppose if this side is charged, then you can find electric field here and everywhere. Okay, but if I am telling you to consider a pair of sheets, that means there must be some difference between this surface and this surface. Are you getting my point? Okay, if I am telling you a pair of sheet, that means there must be some gap. There must be some gap in between the two sheets. Okay, then only you can consider this particular conditions. Okay, and if I am saying you about the where a single sheet is charged. Okay, when I am saying a single sheet is charged, that means only one side of this sheet is charged. Both sides are not charged. Are you getting my point? Okay, so if you are going to consider here, see in this 12 result, 2 results are very, very important. The first one is this one. This is very important. Okay, and second one is this one. This is again very, very important. अच्छा, ये important क्यों है? ये वाला जो रिजल्ट है ये important क्यों है? क्योंकि इससे जस्ट नेक्स्ट क्लास के अंदर हम आपको एक चीज पढ़ाएंगे, that is called capacitor. That is called capacitor. Okay, and capacitor की जो condition है वो ये है. Okay, that means कि this is the form of capacitor. Okay, so in that capacitor, outside left also and outside right also, electric field is 0. Electric field कहाँ होता है? Just in between the two plates. Okay, if this is a capacitor. Okay, see, और अगर आपका कोई भी शीट है, अगर ये लाइटली चार्ज है, अगर ये दोनों के ऊपर जो चार्ज होगा एग्जैक्टली सेम है, तो क्या कंडीशन होगी? You can find electric field outside left, you can find electric field outside right, but the electric field inside or between the plates is 0. But in the capacitor it's totally different. Here 0, here 0, here you will find electric field. Here you will find electric field, here you will find electric field, but here electric field is totally 0. Okay, so this particular condition is again very, very important. क्योंकि जो नेक्स्ट चैप्टर है उस चैप्टर के अंदर हम कैपेसिटर पढ़ने वाले हैं, उसके अंदर आपको ये है कंडीशन, ये वहां पे हम बात करेंगे. ओके.